For our example, we're going to look at data that is related to crime, and we are trying to predict crime in 47 states given different demographic statistics that we have about that state. And we have a host of different data about the percent of people that are male, the age of men. We also have unemployment rates. We have the poverty rates. We also have police expenditures, and we have labor force numbers. We have a bunch of things here, as well as education. I'm not going to get too deep into this. We're not really interested necessarily in discerning theoretically between these right now. What we want to do is use this as an example to showcase how backward and stepwise deletion and model selection can work with the AIC and BIC. So in order to do that, we can first run full reg, and that's just using our crime rate as our outcome. That tilde period is just saying all the other variables that are in the crime data set. And then we can also look for multicollinearity, because most certainly, since we're including all of these variables, we should be a little skeptical of any coefficients that may result from this regression model. Now, we are not interested right now in interpreting or looking for the statistical reliability of our estimated coefficients. So multicollinearity is not going to negatively affect our model fit. Now, that's an important distinction, and typically trying to find the best model based on fit versus the best model theoretically to interpret your coefficients are two very distinct goals. And when we look at this, we can see that, of course, the variables for per capita expenditure on police by state and local government is highly, highly correlated with the expenditures in 1959, right? Year to year, states and local governments don't really change their spending. So the way that we're going to do backward stepwise deletion, we can use the function step in R, and we have our full model here. We have all of our covariates. And what we can see here is that the starting AIC is around 301. And what we can see in each of these columns is when we remove that variable, what is the resulting AIC? And so the variable that would increase the model fit the best if we removed it be NW. So we're going to remove that and then continue on. Now, once we have removed that, it goes and runs again, and we can see that the variable that if we removed it, the model fit would be the best would be LF. Now we're going to do that and check it again, and we can see now that if we remove pop, then we should have a better model fit. We'll do that. Now we can see that if we remove S, we should continue to have a better model fit. And if we remove 59, we should continue to have a better model fit. And then finally, if we remove M, that should be the best model. Now, once we remove that, there is no better suggestion for us. So we are finally at the quote, best model for the smallest subset of variables based on the AIC criteria. And the reason that we did that is because after we remove UI, then it only increases the AIC, right? So that is when the procedure stops, is that by removing any of the variables, we're increasing, so decreasing our model fit by increasing the AIC. So let's actually go ahead and take a look at the final model. And the AIC for our best model is around 291, and that includes the covariates age, ed, x60, U2, M, and POV. So we can do this same process by using a different criteria rather than the AIC, we can use the BIC. And this is just an option within the function step in R. And there's a setting where you have to set k equals something. And in order to do that, we know what the transformation is, and we are just going to multiply it by log n. And so, even though the output still says AIC, it is BIC. And what we can see is that there is a slight difference here, where if we walk through starting with the full model and then removing, we're going to get a very similar output. The only exception is going to be that one, the BIC is going to favor smaller models because it has a higher penalty when we use more parameters. And so you can see that the only variable that we did not select with the BIC versus the AIC is M. And so sometimes these will differ, but most of the time you may end up getting the same answer because there is very little difference between the AIC and the BIC, especially in this case because you only have, age, ed, x60, u2, and POV and M, so about 6 or 7 covariates. This may or may not have a larger discrepancy if the, quote, best models had much larger varying degrees of covariance between them.